All right, hello calculus. This is the Unit 6 review, and as I was writing your test, or picking problems from your test, I was also creating this sort of review. So it will be good for this test, but really I'm hoping this sort of review will be good when you're prepping for the AP test, and you can go back and watch this and just sort of review a lot of concepts from this Unit 6. All right, so here I have a nice little graphic here, and I want you to really pay attention to this description. It's barrels per hour. It is a rate of change. So what I'm actually looking at is the barrels per hour. I'm looking at a sort of a rate of change function here, if you will, sort of B prime. A derivative function is sort of what I'm looking at. The flow of oil in barrels per hour through a pipeline on July 9th is given by the graph shown above. Of the following, which best approximates the total number of barrels of oil that passed the pipeline that day? So this is only giving me a rate of sort of barrels per hour. And so if I want the total number, that means B, the total of number for that time length of one day, that would be integrating from 0 to 24 of this B prime function, okay? And that's just, remember that anytime we integrate, it's really just the area under the curve. All right, well, we can approximate that area. If this is 100 barrels times 6 hours, then this area would be approximately 600 barrels. So in each of these grids, there's 600 barrels. All right, you're doing 100 barrels per hour times 6 hours, you'd get 600 barrels, right? So another 600 and another 600 approximately. And what about this? Well, it's approximately half of one, right? So another 300 and 300, if you will, imagining you were approximating these things. That's 2,400 plus another 600. So I'm going to say it's approximately 300 barrels, all right? Or not 300, 3,000 barrels. There we go. All right. Interesting to think about. Try some more. Again, pause the video so you can write down the questions, and I'm sorry the questions are small. All right. F and G are continuous functions between A and B. And so what I'm going to do is sort of draw what I can. This is the integral from A to B of the F function. So from A to B, I have this F curve, and it's continuous, and I don't know what it looks like, but I'm just going to make a picture. It's F, okay? And the area from A to B, the area under the curve from A to B has P. But it says from C to B. Oh, C is between A and B. So let's pretend that C is right here. Now this is saying the integral from C to B. So from C to B, the area under the F curve is Q. All right. So P is the area under the whole curve, and Q is just this portion in pink, the area under there. So that's Q. All right. Now let's do the same thing. Here I have my G function. So I have another function G. I don't know, starts continuous from A to B. So let's pretend it's that function. All right. So here's the G function. And from A to B, it has an area of R units. But once again, from C to B, and again, C is between A and B. They told us that. So the area between C and B is S units. All right. Then they want to know, what is the area under the curve from A to C of f of x minus g of x dx. Okay, so first of all, I am going to break this stuff up. f of x minus g of x, I can just separate those and subtract. So the integral from a to c of f of x dx minus the integral from a to c of g of x dx. All right. So this is really just properties of integrals. Now, if I want to figure out the integral from just a to c, what I have to do is actually figure out the whole integral. So that would really be the integral from a to b of f of x dx. And then I could subtract the integral from c to b of f of x dx. And if I subtract the big minus part, that's going to give me the leftovers from a to c. Does that make sense to you? Okay. Then here's where it gets tricky. We have to subtract this entire thing. But remember, it's a couple of things, so we have to subtract them both. To get the interval from a to c, I have to take the big minus the small. So that'd be the integral from a to b of g of x dx minus the small interval from c to b of g of x dx. And again, we're subtracting the whole thing. So the signs are going to change. This becomes a to b of f of x was p minus c to b was q. And then we're going to have to distribute our negative, so it becomes minus this interval from a to b of g was r. Minus times minus becomes plus this interval from c to b, which was s. So there we go. P minus q minus r plus s. All right. I'm showing you this notation because if this was a free response question, you'd have to show these integrals. All right, so it's really important that I'm showing you the notation. All right, number 3 here. The graph of f prime. So again, I'm looking at a derivative function is shown above, and they're giving me an initial value of the regular function. So they're giving me a starting value. Which of the following must be true? F of 0 is greater than f of 1. Interesting. These are the original function. I'm looking at a derivative. So if I want my original function f of x would be the integral of the derivative. If we integrate f prime of x, if we integrate f prime of x in terms of x, that's going to give us our big function f, our original function f. Well, the fundamental theorem of calculus says that if I integrate that function from a to b, then that's going to be f of b minus f of a is the integral from a to b of f prime of x dx. Okay, this is the fundamental theorem of calculus that I really hope you're starting to get the hang of. Now, they tell me that f of 0 is equal to 0. That's f of our starting amount here, f of a, all right? So let's see. We're comparing f of 0 and f of 1. Well, f of 1 minus, let me rearrange this. If I rearrange this, f of b would be moving this f of a term, the starting value, f of a plus the integral from a to b of f prime of x dx. Okay, so that was start plus accumulation. All right, so if we want to figure out what f of 1 is, it's going to equal f of 0 plus the integral from 0 to 1 of f prime of x dx. Well, I know f of 0 is 0. And the integral from 0 to 1 of f prime of x dx, well, I don't know exactly what that is, but it's this area from 0 to 1. So it's going to be 0 plus some area. Maybe I'll just call that a. All right. Well, f of 0 is 0. F of 1 is something bigger than 0, right? So this is not true. f of 0 is less than f of 1. All right, because this is something. It's some value a. It's something. Okay, let's see. What's f of 2? F of 2 would be f of 0 plus the integral from 0 to 2 of f prime of x dx. Well, that means it's going to be 0 plus the integral from 0 to 1 and the area from 1 to 2. Well, that's another area. That's area 2. All right. So it's another area there. That's bigger, isn't it? Area 2. Area 1, let's call it area 1, plus area 2. That's going to be bigger. F of 2 is definitely going to be bigger than f of 1. All right. Now, let's see. The integral of f3 f of 3 is, let's see. F of 3 would be the area under the curve, so it would be area 1 plus area 2 minus this portion of area, minus this little area 3 right here, because it's below the x-axis. So it sort of stands to reason that that's going to be smaller than just f of 2. Let's see. I do think probably f of 1. F of 1 now I know that f of 1 is equal to that area 1, as we said before. Now they're saying that f of 1 is greater than f of 3, and we're trying to prove whether that is true or false. So question mark, is f of 1 greater than f of 3? Well, f of 1 is a sub 1, area 1. F of 3 is area 1 plus area 2 minus area 3. Well, I can subtract that area 1. So I really can't compare specifically F1 is greater than F3. I would logically assume it's not. I think that's false. Here, I definitely can say area, I'm just going to stop right there. I can't really compare those specifically. It must be true. No, I don't think that f of 1 is greater than f of 3. No, this is most likely false. All right. So the answer is B. It's 2 only. I think these are hard questions, so I'm trying to show them to you before the AP test. All right, number 4. Let g be the function given by g of x equals the integral from 1 to x of blah-bitty blah-bitty. Which of the following statements about g must be true? Oh, Lord of mercy. Okay, g is increasing on the interval from 1 to 2. G is increasing on the interval from 2 to 3. And g of 3 is greater than 0. So we have 3 things to try and figure out. This is a calculator problem. And you can tell because the function is pretty complicated. This question is also talking about increasing, decreasing intervals. And so if I have my g function here, if I want to talk about increasing, then I need to look at g prime, right? If I know the derivative, if the derivative is positive, then I know g is increasing. That's a good thing to write down. If g prime is greater than 0, then g is increasing. All right, is an increasing function. And that's a good thing to remember. So let's look at the derivative of this function, because looking at this craziness, I don't know. But I can certainly look at the derivative. So then g prime of x would be the derivative with respect to x of the integral from 1 to x of 100 blah, 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 plus 2 e to the negative t squared dt. And this is a crazy function. But what happens when we take the derivative of an integral with these limits, these boundaries? Well, this is that second fundamental theorem of calculus, which says if I take the derivative, when I plug in the number, the derivative of that constant just goes away. And all I have to do then is sort of insert my x's. So that would be x squared minus 3x plus 2 e to the negative x squared. So that is the derivative function, g prime of x. And we want to know, where is it increasing? So we can go directly to our calculator and let's graph it. Oh, man. Oh, that was a different one. All right. So we have x squared minus 3x plus 2 quantity e to the negative x squared. And I'm just going to do my interval is like small numbers, right? So I'm going to do just a decimal window. Zoom decimal just takes me from like -4 to 4. So, wow, okay. So, interesting. Oh, I left off the 100. I was wondering what the problem was. I was like, that didn't look right. Okay, insert 100. Okay, now let me try that. Also, I'm not caring about anything in negative land, so I'm actually going to make my window just go from 0 to 4.7. There we go. Cool. All right, so now I have my graph there, and we can see if g prime of 0, and I'm looking at g prime now. If g prime of 0 is positive, then g is increasing. So let's look from 1 to 2. So I'm just going to use my trace function and type in 1, and I'm right here. So if I were to make a little sketch of this graph, all right, here is where x is 1. And let's see what happens when I push 2. Trace 2. Oh, I'm back here. This is at 2. All right. So I am looking at g prime. And we can see that the function is negative between 1 and 2, which means g would be decreasing. So between 1 and 2, are we increasing? No. And then here, where's 3? 3 is like right here. And it says 3 is 0.0246, yada, yada, yada. So that's a positive value. Between 2 and 3, our function is positive. And we can check other values if we wanted to. G prime of 2.5, let's see. Let's plug in 2.5, is 0.144. That's a positive value. Equals 0.145. So that's positive, which means that is increasing. All right. Now, they want to find, for the third part, g of 3. Well, g of 3 would be the integral from 1 to 3 of that craziness. 100 t squared minus 3t plus 2 e to the negative t squared dt. Oh, but again, that's a calculator question. So let's go and we can plug in a definite integral on our calculator. So I'm going to go to my math menu, and I think it's 9. There we go. And plug in my integral from 1 to 3. There it is, of 100. They do a lot of this. X squared minus 3x plus 2. Do you know how to use your calculator? Questions. E to the negative x squared. And all the people, all the AP readers that I have talked to, it's always, it's so frustrating that they don't know how to use their calculator. Negative 1.942 which is less than 0, not greater than 0. So again, it's 2 only. Right? All right, let f of x equal this craziness. At what value of x is f of x a minimum? Again, minimum, maximum. So we know that we would get a minimum value if our function is going from decreasing to increasing. And so what we want to do is we want to find that critical number by taking the derivative. So f prime of x would be the derivative of this integral. Well, that's a tricky one, which is why I wanted to do this one. Remember, when we take the derivative of that constant limit there, it's going to be 0. We plug in the value, it's just a number, so the derivative then would be 0. But what I do have to take into account is the derivative of this upper limit. And so the second fundamental theorem of calculus day that we did, we have to take the derivative of this, and we are going to plug it in. So the derivative, substituting in, would be e to the x squared minus 3x quantity squared, so just inputting that upper limit. But we have to multiply by the chain rule. When we take the derivative, we've got to remember the chain rule here, so that would be 2x minus 3. Okay, so here is our derivative, and we want to know, when is that set equal to 0? Let me clean this up a little. Oh, I don't want to clean this up at all, actually. This is already a product rule, so we can set each thing equal to 0. And 2x minus 3 equal to 0. Well, this is an exponential function. E to the x. What's e to the x look like? E to the x has a horizontal asymptote. It never equals 0. All right. Here we get 3 over 2. So what's happening to our f prime function at 3 over 2? We know it's equal to 0, and we need to see, does it change from negative to positive? So I'm going to go ahead and pick a value and test a number. Let's try, I don't know, 0. Let's try 0. If I test x equals 0, let's see what happens. When I plug in a 0, this would be e to the 0 times 2 times 0 minus 3. All right, e to the 0 is 1. And then 2 minus 3 would be negative 1. So we get a negative result here. And then over here, maybe I'm going to test, I don't know, 4. Let's try 4. So the 4 squared would be 16 minus 12 squared times 4 times 2 is 8 minus 3 is 5. So e to this number, 4 squared, e to the 16th, what is e? Not quite 3. All right, what is not quite 3 to the 16th? It's a big positive number times a positive 5. So we are going to get a positive result. So because f prime changes from negative to positive, I don't know why I always do that, negative to positive at x equals 3/2, f is a relative minimum. All right. 3 over 2. Now, the reason I wrote this out was because if this was a free response question, this would be the justification that you would need to see. All right. And having, obviously, you don't get points for this, but the readers use it as a clue to tell if you know what you're doing. And obviously, you do have to have that f prime of x notation in there. So seeing all of these things is really important on your free response questions. All right, I'm going to start a part 2 video.